All right, 4.2, properties of quadratic relations. So in this topic, we're just basically going to analyze all of the different properties that make up a quadratic relation. So first of all, the graph of any quadratic relation is what we call a parabola. So that curve that you see, that is called a parabola. You've probably heard the phrase, "Oh, that baseball is falling in a parabolic path." That's where that term parabolic comes from, parabola. So the parabola, it has a whole bunch of different traits about it. First of all, it has a vertex. Now, we've referred to the vertex in the previous lesson. This is that point in the curve where everything switches direction. So this is either the highest or the lowest point on the parabola, depending on which direction it is going. So if the parabola is opening downwards, then the vertex is the maximum point on that parabola. If it is opening upwards, then it is the minimum point on that parabola. That's the vertex. Okay? Now there is a line that travels directly down the center of every parabola, and it splits it perfectly in half. This is called the line of symmetry. The line of symmetry. Sometimes we'll shorten it to just LOS. Line of symmetry is the line that divides the parabola into two symmetric halves. Its equation is x is equal to h. We'll come back to that in a little bit. So its equation is x is equal to h. All right. The x-intercepts. Yeah, x-intercepts. More than one. It's a curve, right? So the x-intercepts are the points where the parabola crosses the x-axis. So in that case, we're looking at part C here. So here are the x-intercepts on this curve. Let's start labeling these things. So we first see the vertex. The vertex is down here, down at the bottom. This is the vertex, okay? And then we have so that's the vertex. The line of symmetry is this line that goes straight down and cuts the curve in half. Let's see how precise I can be while I'm drawing this down. Not too bad. And then we have the x-intercepts. So this is C. So these are these 2 points right here. Those are the x-intercepts. And of course, if we have x-intercepts, we also have a y-intercept. Now there's only going to be one of these for the most part. So we have the y-intercept is the point where the parabola crosses the y-axis. Now in this case, it's right there. Okay? So it's not at the vertex or anything like that. It could be, but it doesn't have to be. So this is the point where it crosses the y-axis. So right here. Okay? Now depending on the parabola that we're drawing, it could be anything. The direction of opening is determined by the a value. The a value. What do we mean by a value? Well, if you remember, we have our standard form of our equation, y is equal to ax squared plus bx plus c. We're going to learn a few more forms, and they're all going to have an a value mostly. All right, so let's see what we mean by this. So if the a value is a positive value, we're going to show some examples of this. If the a value is positive, meaning a is strictly greater than 0, then the parabola opens upwards. So this looks like a curve like this. If it's negative, if a is less than 0, that means that the parabola opens downwards. Like this. Pretty terrible curve, but that's fine. So looking at what we see over here, if we look at this graph here, we want to be able to pull out all the information that we just discussed just by looking at this curve here. So let's see what we can find. Now, if you can't see the axis on the graph here, each line is a value of 1 going in both directions in this situation. So first up, we want to know, what is the direction of opening? Well, it opens up. Think of it like a bowl. So it opens upwards. Now you can write upwards or you can just write up. Either one is fine. What is the coordinate of the vertex? Well, in this case, the vertex is sitting right here at the bottom, and it looks to be at a value of 0, comma, -8. 0, -8. So where is the axis of symmetry? Well, the axis of symmetry is right where it divides everything in line. So this is x is equal to what? Well, this is x is equal to 0. Okay. Where is the y-intercept? Well, the y-intercept here is actually where it crosses the y-axis, and it only crosses the y-axis at this one point, which is at -8. What about the x-intercepts? Well, they're a little bit more tricky. We can see that they're over here. We don't know the exact value, so we're just going to approximate it. It looks like it's about between 5 and 6, so let's say they're at approximately -5.5 and 5.5. Okay? And finally, does it have a min or a max value, a minimum value or a maximum value? This one is opening up, so it has a minimum value, and that minimum value is -8. We can see how so much of the information is actually repetitious throughout this whole thing. Now, we need a little bit more data to work with here, but let's keep breaking this down. Okay? Let's go down to another curve. All right. So for example number 2, let's do the exact same thing we did a second ago, but now we're looking at a much different looking curve. So we see this curve is coming up, and it's going to cross the y-axis here. We can see that it crosses the x-axis here. We can see that its vertex is here, which also means its line of symmetry is going to go straight down here. So we can see all this information. So let's go fill it in over here. First of all, direction of opening. It's opening down. Okay. The coordinate of the vertex. Well, this is at -2, +6. So -2, comma 6. What's the axis of symmetry? Well, that's always going to be it's always going to be the x component of the vertex. So x is equal to -2. Always going to be the x component of the vertex. Y-intercept, it only crosses the y-axis at one location, which is at 0, 5 by the looks of it. Okay. And the x-intercepts. So the x-intercepts are at -7, 0 and 3, 0. And finally, max or min. Well, it's opening down, so that means we have a max. It's a maximum value, and its value is a value of 6. We got all that information. All right, let's look at this next one down here. Now we're given an equation, and we're told for the relation below, complete the table of values, graph the parabola, and state its properties. So just for argument's sake, if you did have a question like this on a test, it'd be worth a fair amount of marks because you're doing quite a bit here. So let's fill it all out first. So we need to fill out our table of values. So substitute each value in our equation, and let's see what we get. So -3 plus 1, that's -2. Square it, we're at 4. 4 times -2 is -8. -8 plus 8 is 0. Yep, you got to go through that whole process for each one of these. -2 plus 1, that gives me -1. Squared, we're at 1. 1 times -2 is -2. -2 plus 8 is going to give me 6. We're going to keep going on this. We're going to end up with 0, 6, 8, 6, 0, -10. Okay, let's calculate our first differences. 6 minus 0, that's just 6. 8 minus 6, that's 2. 6 minus 8, -2. 0 minus 6, -6. And -10 minus 0 is -10. That didn't tell us much. Let's take our second differences. 2 minus 6, -4. -2 minus 2, -4. -6 minus 2 is -2 is -4. And -10 minus -6 is going to give us -4. So we see that its second differences are constant. Okay, that's great. So we know it's a quadratic. We could have told that just by looking at the equation, but whatever. So let's actually graph it in. So -3, 0. -2, 6, all the way up here. -1, 8. And then we have 0, 6. Oh, we flipped directions. And then we have 1, 0, and to -10, all the way down here. So if we draw our curve, okay, label everything x, y. Y is equal to -2 times x plus 1, all squared, plus 8. So we're looking at the same situation as before. We got to fill it all out. So direction of opening, it's opening down. Coordinate of vertex, we can see that it is at -1, 8. So remember, our axis of symmetry is always x is equal to the x component of our vertex, so x is equal to -1. Okay, and then our y-intercept, where does it cross the y-axis? It crosses the y-axis, well, this one's supposed to be right there. I just didn't draw it very well. It should be coming better down here. But right about there, it's at 0, 6. And the x-intercepts. So it crosses the x at -3, 0 and at 1, 0. And then finally, do we have a max or a min? We have a max this time, and its value is a value of 8. So there's all the information we have for this. And that's all we're asking you to do for 4.2, is being able to look at one of these relations and pull apart all the properties just by looking at it, using the graph if necessary, and making sure that you can actually make use of it. So that's it for 4.2.